Ladies and gentlemen, welcome back. Hope you're doing well. Happy Monday. May the 4th be with you. And today we are dilating triangles. It's very interesting. Last time we dilated points where we had a point, we had a center. If the scale factor was larger than 1, the point would get farther away from the center. If our scale factor was smaller than 1, our point would get closer to the center. And it's going to be exactly the same thing here, except we're going to be moving multiple points of a triangle, and I will show you exactly how it works today. So, here's our situation. We have triangle ABC. The new triangle, A prime, B prime, C prime, is going to be a dilation of the center P, whose center is P, and the scale factor is 2/3. So notice, we always go towards the center, so we're moving towards the center, which is P, and the scale factor tells us how far we're moving and in what direction. Because it's less than 1, we're going to be moving closer. So each one of these points is going to be closer. The question is how much closer? Well, the answer is 2/3 of the way. Let me show you. Let's take it step by step. I'm going to do one point at a time. A, notice, it's going to travel from A and it's going to move closer to P. The question is how far? Well, it's 2/3 of the way. So if we separate this distance into thirds, it's going to be approximately 2/3 its normal length. This was its regular normal length from A to P. I want it to be 2/3 of that size, so I put it right there at the 2/3 mark. Same thing with B. Here's the distance from B to P. B is going to be moving towards P. The question is how much? Well, it's going to be 2/3 of its normal length. So let me put where B would be 2/3 of the way away from P. Same thing with C. Here's where C, the distance it is from P, the scale factor is 2/3, so I need it 2/3 of the regular distance. So there's my new points, and there is my new triangle. You can see it. I'm drawing it in red here. Whoops. Kind of looks ugly. Not the great artiste. But notice, it's the same size, or it's not the same size, it's the same shape. It's gotten smaller, and it's moving closer to P. So that's our rough sketch. We just have to find the one that looks similar to that. It looks like C. That's bravo. Draw the image ABC using a dilation whose center is P and the scale factor is 3. All right. I like to start with the original shape. So we have this original 3, 4, 5 triangle. Each one of these points, it's going to be getting bigger. It's going to be getting farther away by a factor of 3. And it's moving away from P. So watch this. We're going to do it one at a time. We have A here, right? A, it's being dilated through a center of P, so it's going to be moving away from P because the scale factor is 3. So it's going to be moving 3 times farther away. So notice A, relative to P, is 1, 2, 3, 4 units away. So right now A and P has a distance of 4. If that was 3 times bigger, it would be 12 units away because 3 times 4 is 12. So I'm going to count 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's where A is going. Next, let's move C. C is a little bit trickier because, notice, it's diagonal. And I don't want to count diagonal distance. I want to count up and down, or up and down, left and right distance. So to get from P to C, notice we have to go down 1, 2, 3. To the left, 1, 2, 3, 4. And let me actually draw it like a chart here. Here's P, and here's C. Okay. To get there, I said we counted down 3 and to the left 4. Okay. We need to make each of those bigger by 3. So if I drew this bigger by 3, 3 times bigger than down 3 would be down 9, and 3 times bigger than to the left 4 would be to the left 12. Okay, that's 3 times bigger going in the same direction. So notice, I'm going to count, instead of counting down 3 with C into the left 4, I'm going to count down 9 into the left 12. So let's count. It'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll go to the left 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful. And then with B, same thing. We went down 3. 3 times bigger than 3 is 9, so I need to count down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So we have a brand new triangle. It's 3 times bigger relative to P. All the distances between the lines, between the points, are exactly 3 times larger. And it's the same shape. So it looks like I've done it correctly. Bravo. Ooh, this one's interesting. Notice we have all these points. It says, draw the image of triangle ABC under a dilation whose center is A and the scale factor is 1/4. So that's interesting. This is a little bit different for 2 reasons. Our center, where we're going towards, is actually a part of the triangle. We're going to be moving towards a point on the triangle. So A is not going to be moving at all because that's the center. But this time we have a scale factor of 1/4. So it's going to be actually getting smaller by 1/4. So we're going to have to calculate each of these. We're going to have some diagrams. Let me start with A and B. It roughly looks like this, yeah? Okay. We're going to have to count how far away these points are. Going up from A to B, it looks like it's 1, 2, 3, 4. And to the right, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have up 4 to the right 12 to get to B. Well, I need 1/4 of that. So we're going to divide both of those by 4. Obviously, 4 divided by 4, 1/4 of 4 is 1. And 12 divided by 4, which is 1/4 of 12, is 3. So instead of going all the way over here, I'm really only going to go up 1 to the right 3. Same thing with C. I'll draw a diagram. Here's A, and here's C. Let's count how much that goes. It goes down 1, 2, 3, 4, 5, 6, 7, 8. And to the right, 1, 2, 3, 4, 5, 6, 7, 8. Well, that's easy because 1/4 of 8 is 2 and 2. So we're going to go down 2 and to the right 2. 1, 2, 1, 2. So there's our triangle. It's being dilated towards A, so A is not moving. All of the points of the triangle are moving towards A, and the triangle is going to be 1/4 of the size. So we just calculate the distance between the points, make it 1/4 of the original length. There's our triangle right there. Probably one of the more tricky ones, but not too bad. Here we go. Triangle A prime, B prime, C prime is the new image of ABC under the dilation whose center is P and the scale factor is 1/4. So again, the triangle is going to be getting smaller because the scale factor is less than 1. All of the points are going to be, the distance to that point is going to be 1/4 of the original length. So notice A and B is really easy because they're going to be moving towards P, and it's going to be 1/4 the original size. So it's actually going to be really close to P. Really close to P. That's our new A and our new B. C, though, notice here's the distance from B to C, and it's going to be 1/4 of the way. So you can imagine halfway would be about right here. So 1/4 would be right there. And here's our new little triangle. It's been dilated towards P, and it's 1/4 of the original size. It's real small. So let's see if we can match up one of those. We can. Bravo. It's D. Awesome. Well, keep going, keep growing, dilating triangles. Let me know if you have any questions, and we will see you next time.